Alrighty friends, today we're on 9-7 polygons in the green book on page 234. The objectives here, I'm not going to read them to you, but I do want you to copy them down into your notebooks. Okay, so pause the video, hit play when you're ready to move on. Okay, a polygon is a closed plane figure that has three or more sides. Each side is a line segment. The line segments meet only at their endpoints. These are the vertices of the polygon. So we have a vertex right here, vertex right here, right here, right here, and right here. These are all made up of line segments, okay? Our interior angles are the ones here in the brown, okay? Our exterior angles of a polygon look like this. So this would be like if you extended the line of one of the sides. So like over here would look like right there. Again, these are not straight, I know. But then this would be an exterior angle right here or right here, okay? Same thing if I wanted to make it on this side. The exterior angle will be on this side, okay? Alrighty, there's convex and there's concave polygons. An easy way to remember concave polygons is where one of the sides of the polygon goes back into the figure, so it caves back in. So this part right here where it caves back in makes this a concave polygon. Alright, convex polygons, so each angle in a convex polygon are less than 180 degrees, okay? So each of these are less than 180. In a convex polygon, there's at least one or more that are greater than 180, okay? Alright, so now let's talk about a regular polygon. A regular polygon has congruent sides and congruent angles. So for instance, if we drew a nice perfect square, again, I know mine are not perfect, but each side is congruent. You can tell that by the same dash marks as well as the 90-degree angle marks. So this is a congruent polygon. Same thing if I drew, I know it doesn't look like it, but this is congruent. Just a terrible drawer. So they all have the same dash marks. And they all have the same angle marks right there. So that is congruent. Okay, each angle has the same degree and each side is the same length. Okay? All regular polygons are convex polygons. So please put that in your notes. All regular polygons are convex polygons. Okay? Alright, let's talk about a triangle. A triangle is a polygon with three sides. Again, terrible triangle, I know. Alright? It has three vertices, or three endpoints. So right here, right here, right here. Okay? We know that the sum of the interior angles of a triangle will equal 180 degrees. We know that. Okay? Each of the interior angles, oh wait, I just said that. Sorry. Okay. Okay. Let's go on to finding the measures of any polygon's interior angles. Okay? So, alright, so this is how we're going to start seeing the degree of each polygon with drawing vertices. Okay. So what we're going to do is we're going to start at one of the vertexes. I'm going to start at this one. Actually, let's start this one right here. I'm going to start down here. Okay, I'm going to pick this vertex. I'm not using a straight edge because I can't use it on this iPad, but you would want to use this on your paper. Okay, so starting at one of the vertexes, any one that you'd like, you're going to draw as many diagonals, which is a line segment that connects two non-adjacent vertices. Okay, so for instance, this one right here is a non-adjacent vertex, and this one right here is a non-adjacent vertex, okay? So I'm going to draw my straight line right here, straight line right up here, okay? Now, that is the maximum diagonals that I can draw across this from this particular point. The next step here is seeing how many triangles that we just created. So we created one triangle here, one triangle here, one triangle here. So what we do is we take the number of sides, okay, which is 5 here. One, oopsie poopsie, don't do that to my girlfriend. Which is 1, 2, 3, 4, 5. This is a pentagon. So we do the number of sides, which is 5, minus the number of, that's weird, hold on. Okay, my bad. So we do 5, so number of sides minus 2 equals the number of triangles. So we do, let's do this, let me write that for you. So we have number of sides minus 2 equals number of triangles. Okay? All right, let's do another one. Let's do... Make sure we go back to this bad boy. Okay. Alright, how to find the measure of each angle of a polygon and how to find the sum of all of the angles in a polygon. Again, these are we're just referring to regular polygons here. Alrighty. So if I have a pentagon, okay, it's 5 sides, right? And I'm not going to draw it because it'll be a total mess. Nobody wants that. So a pentagon has 5 sides, right? Okay. So we do the number of sides or vertices minus 2 times 180 all over number of sides. Okay? So let's do this little nugget over here. So our number of sides is 5. So we have 5 minus 2, which is 3. Actually, we're just going to erase that. Put that up here. So we have 5 minus 2, which equals 3. So we have 3 times 180 divided by 3. So this one that we're doing right here, we're finding each individual angle measure here. Okay? 3 times 180. Actually, for easier math, let's simplify this. So we're going to do... I am so sorry. I keep messing this up. This needs to be over the number of sides, 5. My bad, my bad, my bad. Okay. So, let's simplify this. So 180 and 5 can be simplified. That can go down to 1. That's going to simplify down to 36. So 36 times 3 is going to give us 108. So in a regular pentagon, each angle is going to be 108 degrees. Now if I wanted to find out how many sides that I needed, you could multiply this by 5, and that would give you that total number, which should be 540, I believe. I think I'm right. 540 degrees. Okay? All right, let's do that again. Let's do a 7-sided figure, okay? 7-sided polygon. Polygon. Actually, no. I'm going to write that differently. I'm going to actually use the name. Let's do heptagon, which is 7 sides. 7 sides, 7 vertices. Okay. So I want to know what all the angles together measure in a regular heptagon, and I want to know what each angle measure is. So let's do this bad boy. So we have 7 minus 2 times 180 divided by 7. Okay? It's going to be 5 times 180 over 7. Okay? So let's do that math. Let's do 180 times 5. It's going to be 0. 5 times 4 is 0. Alright, so that's going to be 900. I'm sorry for my slow math skills. So we have 900 divided by 7. Whoa. Really? That's weird. So this is going to be actually a decimal. Okay? So the total number of sides is going to be the total number of sides. Oh my gosh. When you add up all the interior measures of the angles of a heptagon, the total measure of all the degrees, it will be 900 degrees. But for the individual degrees, it's going to be about 120, just about 129 degrees for each angle. Okay? Now, when you did that, yeah. So this was a decimal, so this was about. But if you just multiply the number of sides minus 2 times 180, it'll give you that total number right there. All right, so let's do an octagon. 8 sides. Octomom, right? Just kidding. Okay, an octagon. Okay, let's do 8 minus 2 times 180 for my total degrees. So 6 times 180, the sum of all the angle measures, so 180 times 6. So that is going to be 1,080 degrees. For each individual measure, we're We're going to divide 1,080 by the number of sides, which is 8. So each angle is going to be in a regular octagon. Each angle is going to be about 135 degrees. Okay? Alrighty, I want you to try these 1 through 6 right now, please. And remember, we talked today about angle measures being supplementary. Okay? So you're doing the try these numbers 1 through 6. All. Okay, use your notes, and I will see you guys tomorrow. Bye.